So I'm 99.99% confident that everybody in here got exposed to absolute value in their K through 12 education, right? But we'll reintroduce the idea just to play it safe. So the absolute value of a real number x, denoted with this notation, right, with the vertical bars around the variable x, geometrically describes the distance from x to 0 on the real number line. So I provided you with a real number line. So here is the number 5 to the right is 0, and here is the number 5 to the right is 0, and here's the number -7 to 11 is 0. Right? So the distance of the number 5 to the number 0 is 5 units. So we say the absolute value of the number 5, right, is equal to 5. And the distance of the number -7 to 0 is 7 units. So we say the absolute value of -7 is 7. Okay? So you can think of absolute value as measuring how far a number is from the number 0 on the real number line. So we can define the absolute value of x, okay, as a function. So in the rectangle, I guess I don't have to write it on 4. Okay. So the absolute value of x is just equal to set itself if x is greater than or equal to 0. Right? And then we demonstrated that here, right? 5 is greater than 0, so absolute value of 5 is just 5. Okay. And the absolute value of x, okay, is equal to the negative of itself if it's less than 0. Right? You got remember, minus x is the same as negative 1 times x. So if x is less than 0, you got to multiply by negative 1 to make it positive. Okay. All right. So that first property, right, absolute value of x is equal to x, right? If x is equal to 2, we have the absolute value of 2 is equal to 2. And if x is negative, less than 0, like -3, then the absolute value of -3 is equal to the negative of -3, which is +3. Okay. That's all that this is saying here in our definition of absolute value, okay, as a function. All right, properties of absolute value. The first property, right, A is some real number, okay? And so the first property says absolute value of A and absolute value of negative A are the same. So let's say A is equal to 4. What that property is saying is the absolute value of +4 and the absolute value of -4 are equal, right? Because the absolute value of 4 is 4, and the absolute value of -4 is 4. Property 2 says the only way you can take the absolute value of a number and get 0 is if the number is equal to 0. Okay? So all that property 2 is saying is the absolute value of 0 is 0. Okay? If you take the absolute value of something gets 0, that something has to equal 0. Property number 3 says the absolute value of a product, right, is equal to the product of the absolute values. Okay? And property 4, okay, says, let me move up. Property 4 says the absolute value of a fraction is equal to the absolute value of the numerator divided by the absolute value of the denominator. So those are some properties of the absolute value. So let's do some exercises involving absolute value. In the exercise below, we got to write the absolute value of x minus 8 without absolute value bars. Okay? So how are we going to do that? Well, remember, from up above, right, the definition of absolute value of x is the absolute value of x is equal to itself if x is greater than or equal to 0, and it's equal to the negative of itself if x is less than 0. Okay. So in answering this question, okay, on the left, we're given in the first case, right, that x is less than 8. Okay. To answer this first question, all we're going to do is replace x in our definition over here. Wherever you see that there's 5 x's, 1, 2, 3, 4, 5. We're going to replace each of those 5 x's with x minus 8. And so when we do that, we have the definition, the absolute value of x minus 8 is equal to x minus 8 if x minus 8 is greater than or equal to 0, and x minus 8 is equal to the negative of x minus 8 if x minus 8 is less than 0. Okay. So for the case where x is less than 8, right, we have to determine which of these two is true, and then we can remove the absolute value bars. Okay. So we are given that x is less than 8, right? That's what we're given. And you know, I can subtract 8 from both sides of that inequality. I have x minus 8 is less than 8 minus 8. So I have x minus 8 on the left, but 8 minus 8 is equal to 0. So if x is less than 8, then x minus 8 is less than 0. So that means the absolute value of x minus 8, because x minus 8 is less than 0, the absolute value of x minus 8 in this case has to equal the negative of x minus 8. Okay. So to figure that out, all they did was tweak the definition of absolute value, replace the x's with x minus 8. So since x minus 8 is less than 0, right? You know, anything less than 0 is negative. We have the absolute value of x minus 8 is equal to the negative of x minus 8. And that's the answer to this problem. Does everybody understand what I did? I took the definition of absolute value over here, okay, and I just replaced all the x's with x minus 8 so that I could determine, right, given x is less than 8, determine whether the absolute value of x minus 8 is equal to itself or the negative of itself. Okay. All right. In the next case, we have absolute value of x minus 8 where x is equal to 8. So that's easy to do, okay? Because we're not dealing with it, we're dealing with an equality, not an inequality. And so the absolute value of x minus 8 in this case, you just put in 8 in for x, right? Because that's what it's equal to. We're given that's what x is equal to. And you know 8 minus 8 is 0. And the absolute value of 0 is 0. And so that's the answer. The absolute value of x minus 8 in this case is equal to 0. Any questions on it? So you flip over your page. Now we're going to do something a bit more complicated. We have an algebraic expression involving absolute value. So we're going to write this expression without absolute value symbols, right? So we got to get rid of the two absolute values, okay? But we're given some information about the variable x. And in A, we're given that x is between -1 and 3. All right. So like we did with this problem, okay, we got to define the absolute value of x plus 1 and the absolute value of x minus 3. So again, just as a reminder, absolute value of x from page 1 is equal to x if x is greater than or equal to 0, and minus x if x is less than 0. So we're going to do like we did with this problem over here, or the previous problem. We're going to replace all 5 x's with x plus 1. And we have the absolute value of x plus 1 is equal to x plus 1 if x plus 1 is greater than or equal to 0, and it's equal to the negative of x plus 1 if x plus 1 is less than 0. We're going to do the same thing for the absolute value of x minus 3. The absolute value of x minus 3 is equal to itself if x minus 3 is greater than or equal to 0, and it's equal to the negative of itself if x minus 3 is less than 0. Okay? So both cases, all I did was replace the 5x's with either x plus 1 or x minus 3. So let's deal with the first part of our expression, the absolute value of x plus 1. Okay. But first, in A, we're given that x is in the interval, the half open interval from -1 to 3. What does that mean? That means x is greater than or equal to -1 and less than 3 in inequality notation. Right? Remember, this is interval notation and this is inequality notation. Okay. So this is saying that the variable x, right, is greater than or equal to -1 and strictly less than 3. Okay. All right. Well, if I add 1, right, so we're interested in the absolute value of x plus 1. So if I add 1 to all 3 sides, okay, I get x plus 1 in the middle. Right, remember this is called a combined inequality. Okay. Just to reiterate, right, this is called a combined inequality. And so if I add 1 to all 3 sides, Remember, whatever I add to one side, I gotta add to all three sides. And so minus 1 plus 1 is 0 on the left. We have x plus 1 in the middle. And on the right, we have 4, right? 3 plus 1 is 4. Okay. So x plus 1 is greater than or equal to 0, right? Being less than 4 is not what's relevant. Okay? What's relevant here is this inequality, right? I can flip the inequality over, and I have x plus 1 is greater than or equal to 0, right? That's what this part of the inequality, combined inequality, is saying. Well, if x plus 1 is greater than or equal to 0, then the absolute value of x plus 1 has to be equal to x plus 1. Okay? So the absolute value of x plus 1 is equal to x plus 1. Okay? If x is between minus 1 and 3. Now we do the same thing for x minus 3. We're given minus 1 is less than or equal to x, which is less than 3. But now I'm going to subtract 3, right, from all three sides to get x minus 3 in the middle. So we have minus 3 on the left, minus 3 in the middle, minus 3 in the right. Minus 1 minus 3 is negative 4. In the middle we have x minus 3. And on the right we have 3 minus 3 is 0. So x minus 3 is greater than or equal to negative 4 and less than 0. So the part of this inequality that's important is this part right here. X minus 3 is less than 0. Right? That's what's important. And so our definition of the absolute value of x minus 3, it says if x minus 3 is less than 0, what's the absolute value of x minus 3 equal to? The negative of x minus 3. So the absolute value of x minus 3 is equal to the negative of x minus 3. Can you see that, what I just wrote here? Can you see that? Because I mean, the stand there, I don't know if the stand is blocked, but you can see what I wrote right here. Everybody, can you see it? You can't see what I wrote right here.
I like to know what it is.
Huh?
I like to know what you wrote. I can't see it.
Can you see this?
Yeah.
Can you see this?
Yeah.
But you can't see this. That's what I need to know. Okay? So I know where to write. So absolute value of x minus 3, right, we conclude is equal to the negative of x minus 3. Okay. Everybody with me so far? Yes, ma'am.
Why'd you put a less than?
Oh, so that is a very good question. And I had a dyslexic moment. Okay? Yeah. That happens sometimes. I have a dyslexic moment. We all have them. Okay. Working with numbers and variables all the time. Okay. Yeah. So the absolute value, right, of x minus 3 from our definition is equal to the negative of x minus 3. And I want to bring up a point. If I make a mistake up here, right, you don't have to say something. Okay? Don't let me go on for 45 minutes with a math error up here, okay? Because it happens. So I'll get mad at you if you don't say it. I'll be eternally grateful if you do say something. Okay, that's what I want to emphasize. Okay. Yeah, so the absolute value of x minus 3 is equal to the negative of x minus 3. Okay. So we're not done. We just figured out how to replace the absolute value of x plus 1 and replace the absolute value of x minus 3, right? So the last step is replacing those two absolute values with what they're equal to. So absolute value of x plus 1 minus the absolute value of x minus 3 is equal to absolute value of x plus 1 is x plus 1. And then we subtract minus x minus 3. So we got a double negative, right? So we got minus. So maybe we ought to do it this way. Always wrestle how to write double negatives. So this is actually minus 1, right? So we have x minus, absolute value x minus 3 is equal to negative 1 times x minus 3. So if I multiply both sides by negative 1, I have negative 1 times the absolute value of x minus 3 is equal to negative 1 times negative 1 times x minus 3. Well, negative 1 times x minus 3 is just the negative of x minus 3. And then negative 1 times negative 1 is 1. And then we have times x minus 3 in parentheses. So minus absolute value of x minus 3 is just equal to x minus 3. We're adding x minus 3. Right? Now, instead of writing it as minus x minus 3. Okay. And now you combine like terms, x plus x is 2x, and 1 minus 3 is negative. So the absolute value of x plus 1 minus the absolute value of x minus 3 can be written as 2x minus 2. Okay. For any number in that interval. And we can do a test to see if it show you that it works. Right? 0 is between minus 1 and 3. So if I put in 0 in for x on the left-hand side, I have absolute value is 0 plus 1 minus the absolute value is 0 minus 3. And that has to equal 2 times 0 minus 2. Right? I just put 0 in for x. Well, 0 plus 1 is 1, and absolute value of 1 is 1. 0 minus 3 is negative 3, and absolute value of negative 3 is plus 3. So I have 1 minus 3 on the left. And on the right, 2 times 0 is 0. So I have 1 minus 3 is negative 2 on the left. 0 minus 2 is negative 2 on the right. That's a true statement. So it works. Okay. So given that x is between minus 1 and 3, we can rewrite the absolute value of x plus 1 minus the absolute value of x minus 3 as just 2x minus 2. Okay, for that interval. Any questions on that? Okay. All right. So in B, the interval changes. So we still have the same definition for absolute value of x plus 1 and absolute value of x minus 3. But now the interval is from minus infinity to minus 5. Right, that's all real numbers. strictly less than minus 5, right? So we have x is less than minus 5. Right? This is all from 1.1 interval notation. Right? This is the interval notation for all real numbers less than minus 5. This is the inequality notation. All right. So first we got to figure out whether x plus 1 is positive or negative. So we add 1 to both sides. Whatever you add to one side, you got to add to the other side. And we get x plus 1 is less than, minus 5 plus 1 is less than negative 4. And is negative 4 less than 0 or greater than 0? Less than 0, right? So x plus 1 is less than 0. So if x plus 1 is less than 0, then the absolute value of x plus 1 is equal to what? From our definition, and you wrote them down, I hope. The absolute value of x plus 1 is equal to what if it's less than 0? Negative x plus 1, right? I hope you wrote down the definitions. Okay? Because if you don't understand the definition for the absolute value of x plus 1 or the absolute value of x minus 3, you're not going to know how to solve the problem. Now let's see whether absolute, x minus 3 is positive or negative. So x is less than negative 5. And so we subtract 3 from both sides. And we get x minus 3 is less than negative 8. Is negative 8 greater than 0 or less than 0? Less than 0, right? So x minus 3 is less than 0, right? So if x minus 3 is less than 0, the absolute value of x minus 3 is equal to what? Negative of x minus 3. Okay? So, we have a similar issue that we had from last time. Absolute value of x plus 1, in this case, is equal to the negative of x plus 1. Okay. And minus the absolute value of x minus 3. Right? If I take the negative of both sides, right, I have negative absolute value of x minus 3 is equal to a negative times a negative, which is positive. So negative of the absolute value of x minus 3 is equal to plus x minus 3. Right? Negative times a negative is positive. And so this is equal to minus x plus 1 plus x minus 3. And now, to simplify, you got to distribute the minus sign inside the parentheses, right? That's the same as multiplying by negative 1. And I get minus x minus 1 plus x minus 3. Minus x plus x is 0. And I'm left with negative 4. So this says, for any real number less than negative 5 that I put in for x up here, the left-hand side will equal negative 4. Okay. So, Kirsten, give me a number less than negative 5.
Negative 6.
Negative 6. So let's put negative 6 in for x. You have minus 6 plus 1 minus the absolute value minus 6 minus 3. And according to our formula, this has to equal -4. -6 plus 1 is -5. -6 minus 3 is -9. Well, absolute value of -5 is 5. Absolute value of -9 is 9. So we have 5 minus 9 is equal to -4. And that is a true statement. Okay. And so this will work. No matter what number you put in for x, it's less than -5, the left-hand side will equal -4. Any questions on that? All right. The distance between two numbers on the real number line. So here's my real number line. And here's A and here's B, right? Just two numbers on the real number line. Okay? The distance between those two numbers is just the difference between those two numbers, taking the absolute value of the difference. Okay? If you do A minus B in this case, the way I wrote it up here, you'll get a negative number. So you take the absolute value of that negative number to get the distance between the two. Okay? All right. The midpoint is the halfway point between the two numbers. Okay? And so the distance between A and the midpoint equals the distance between the midpoint and B. So we'll label the midpoint M. Okay? And it's just the average. The midpoint is just the average of those two numbers. Okay? It's like finding, you get two test scores. It's like finding the average of two test scores. So in the exercise below, you're asked to find the distance and the midpoint of the line segment between the numbers -100 and 255. So here's -100, here's 255. Okay. So the distance right, using this notation, right, this stands for distance between -100 and 255. It doesn't matter what order you do the subtraction as long as you take the absolute value, is equal to the absolute value of -100 minus 255, which is equal to the absolute value of minus 355, which is equal to 355. Okay. So you just take the absolute value of the difference of the two numbers, okay, to find the distance. To find the midpoint, we just average the two numbers. And so the midpoint M is equal to -100 plus 255 divided by 2. Which is equal to 155 halves, or 77.5. Now, most of the time in mathematics, we prefer to write things within proper as an improper fraction. Right? This is an improper fraction, and not as a decimal. But there are cases where we write things as a decimal, especially answers to particular word problems. Okay. Doesn't make sense to give a speed as 155 halves. Makes more sense to talk in speed as 77.5 miles per hour. Okay. But most of the time we When we're just doing algebra, we prefer the answer is an improper fraction. All right. Any questions on that? All right, at the top of the next page, let M be the midpoint of the line segment joining A, the left endpoint, and B, the right endpoint. Let A equal 10, and then the distance from the midpoint to B is 5. So we got to find the midpoint M and the right endpoint B. So let's draw a good picture. A is the left endpoint, B is the right endpoint, and M is A is the left endpoint, B is the right endpoint, and M is the midpoint. Okay? Well, we are given, okay, that the left endpoint A is equal to 10, and the distance from the midpoint to B is 5. So the total distance from M to B, right, is 5 units. And so we got to figure out what M and B are. Okay? Well, riddle me this. If the distance from the midpoint to B is 5 units, what's the distance from A to M? 5 units, right? Because this is the midpoint, right? So the distance from A to M is also 5 units. Okay. Well, if A is equal to 10, and the midpoint is 5 units from A, what's M equal to? 15, right? So M is equal to A plus the distance from A to M. Well, A is 10. The distance from A to M is 5. And so the midpoint has to be 15. Are you with me? So that's one answer, right? Now riddle me this. The midpoint is 15, and the distance from the midpoint to B is 5 units, then B has to equal 20. So B is equal to the midpoint plus the distance from the midpoint to B. So B is equal to 15 plus 5, so B is equal to 20. And we're done. Okay. Now there are other ways you could have got these answers. Okay. But for me, this was the shortest. All right. Any questions on that? All right, so let's go ahead and take attendance.